So far in this course, you've learned about different kinds of database objects like views, functions, operators, etc. to write complex queries and to combine, compare, or manipulate data. Microsoft SQL Server implements support for SQL windowing operations, which gives you the ability to define a set of rows and apply several different functions against those rows. Once you've learned how to work with windows and Windows functions, you may find that some type of queries which appear to require complex manipulations of data aren't required anymore. In this module, you'll learn the benefits of using window functions, how to restrict window functions to rows defined in an over clause, including partitions and frames, and how to write queries that use window functions to operate on a window of rows and return ranking, aggregation, and offset comparison results. Before we learn how to create Windows functions with over clause, let's see what they are. Window functions belong to a type of function known as a set function, which means a function that applies to a set of rows. The word window is used to refer to the set of rows that the function works on. One of the most important benefits of window functions is that we can access the detail of the rows from an aggregation. SQL Server provides a number of window functions which perform calculations such as ranking, aggregations, and offset comparisons between rows. In order to use these functions, you will need to write queries that define windows or sets of rows. You will use the over clause and its related elements to define the sets for the window functions. In this lesson, you will learn the different windowing functions, the different components for windowing, and how to write queries that use the over clause with partitioning, ordering, and framing to define windows. Let's get started with SQL windowing. SQL Server provides windows as a method for applying functions to sets of rows. There are many applications of this technique that solve common problems in writing T-SQL queries. For example, using windows allows the easy generation of row numbers in a result set and the calculation of running totals. Windows also provides an efficient way to compare values in one row with values in another without the need to join a table to itself using an inequality operator. There are several core elements of writing queries that use windows. Windows allow you to specify an order to the rows that will be passed to a window function without affecting the final order of the query output. Windows include a partitioning feature which enables you to specify that you want to restrict a function only to rows that have the same value as the current row. Windows also provide a framing option which allows you to specify a further subset of rows within a window partition by setting upper and lower boundaries for the Windows frame. And they can simplify queries that need to find running totals, moving averages, or gaps in data. Let's take a look at this example. In this example, the query uses the over clause along with the aggregate function sum to return a running total of the quantity per product category. The running total will reset to 0 at each change in the category mentioned in the partition by clause and is the sum of all the previous rows in the current category up to the current row as mentioned in the framing. You can also notice that we have an order by clause as a part of calculation, and it won't affect the order of input or the final output order of the result set. Let's execute this query and see what the results will look like. Let's open a new query and paste the query that we just saw. Click on Execute. And it will return the category, the quantity, the order year, and the running total for each of those categories. So for each of these categories, the running total is reset to 0 at the change of the category. Now let's add an order by clause to the query and see what happens. Let's order it by quantity. Click on Execute, and the result set is ordered by quantity in the ascending order, irrespective of the order by mentioned in the over clause. Now let's change the order by to category. Click on Execute, and the resulting set is ordered by category. Let's see what happens if you remove everything from the over clause. Click on Execute, and it returns the running total for the entire table instead of each category. Now that we have played with the different windowing components, let's see how they are related with each other. In order to use windows and window functions in T-SQL, you'll always have to use one of the subclauses that create and manipulate windows, which is the over subclause. Additionally, you may need to create partitions with the partition by option and even further restrict which rows are applied to a function with framing options. Therefore, understanding the relationship between these components is vital. The general relationship can be expressed as a sequence with one element further manipulating the rows output by the previous element. The over clause determines the result set that will be used by the window function. An over clause with no partition defined is unrestricted and it returns all rows to the function. A partition by clause, if present, restricts the results to those rows that have the same value in the partition columns as the current row. For example, partition by customer ID restricts the window to rows with the same customer ID as the current row. Partition by builds on over clause and cannot be used without an over clause. An over clause without a window partition is considered as one partition. And then there is the frames. A row or range clause creates a window frame within the window partition which allows you to set a starting and ending boundary around the rows being operated on. A frame requires an order by subclause within the over clause. Now let's see how to use the over clause. The over clause defines the window or set of rows that will be operated on by a window function, and it includes partitioning, ordering, and framing where each of them is applicable. When the over clause is used alone, it does not restrict the result set passed to the window function, and when it is used with the partition by subclause, over restricts the set to those rows with the same values in the partitioning elements. And if you need multiple over clauses, they can be used in a single query, each with its own partitioning and ordering. The syntax of the over clause is as shown here. Let's take a look at some examples. In the first example that you see here, since there is no partitioning information in the over clause, it calculates the sum using all the rows in the underlying query's result set. In the second example that you see here, since it is partitioned by column, it calculates the aggregate once for each window of rows restricted to only those rows that have the same value in the column as in the current row. Now let's see some examples to see how to use the over clause. Let's open a new query and let's do a simple select category, quantity, and the order year. And let's use the row number function over, let's use the order by clause for the quantity in descending order and call it running from sales.category quantity year. And let's order the result set by running. Let's click on execute. And as you can see, we are using the over clause without an explicit window partition to define an unrestricted window that will be used by the row number function. All rows will be numbered using an order by clause which is required by the row number function, and the row numbers are displayed in a new column called as running. Now that we have seen how to use the over clause, let's see how to partition the windows. Partitioning a window limits a set to rows with the same value in the partitioning column, and you can use a partition by with the over clause. Partition by clause cannot exist without the over clause. And as you've already learned, if there is no partition defined, then the over clause returns all the rows from the underlying query's result set to the windows function. Let's take a look at this example. In this query, we are using the partition by subclause in the over clause to create a window partition for rows with matching customer IDs. When you execute this query, it will return the customer ID, the order month, and the quantity that the customer ordered in that month, along with the total quantity ordered by the customer. Partition is conceptually similar to a group by clause, even if the mechanisms are very different. Let's execute this query and see what the results will look like. Let's open a new query, paste the query that we just saw, and click on Execute. So all the partitions are by customer ID. Let's see what happens if we delete the partition. Click on Execute, and it will return the total by customer for every customer in the table. Now let's add a partition to this query that we saw earlier. Let's partition it by category. Partition by category. Click on Execute. And as you can see, in the result set, all of 2007 is numbered as 1, 2008 is numbered as 2, and 2006 is numbered as 3. Since we've added a partition by subclause to the over clause, we created a window partition for rows with matching category values, and this allowed the row number function to number each set of years per category separately. Now that we've learned how to partition the windows, let's learn about ordering and framing the windows. As you've learned earlier, window partitions allow you to define a subset of rows within the outer window defined by the over clause. In a similar approach, window framing allows you to further restrict the rows available to the window function. You can think of a frame as a moving window over the data, starting and ending at positions you define. And to define the window frames, you need to use the row or range subclauses and provide a starting and an ending boundary. Unbounded means go all the way to the boundary in the direction specified by preceding or following clause. Current row indicates start or end at the current row in the partition. Rows between clause allows you to define a range of rows between 2 points. And when defining these window functions, ordering provides a context to the frame. Since over clause returns a set and sets have no order, an order by clause is required for the framing operation to be useful. This can be different from the order by clause, which determines the display order for the final result set. Without ordering, start at first row is not useful because a set has no order. Now let's take a look at an example to see how ordering and framing works. Let's use the example that we've seen before. Let's delete this row number function and add an aggregate function to get the total quantity. And now let's add the rows between clause. Let's add rows between unbounded, preceding, and the current row. Let's change the order by to order year. Let's delete the order by clause and click on Execute. This example uses framing to create a moving window where each row is the end of a frame starting with the first row in the window partitioned by the category and ordered by year, and the sum function calculates an aggregate in each window partition's frame. Which means for each of these rows, a running total is calculated, and when a new category is hit, the running total is reset to 0 and starts all over again. So far in this module, you've learned about the different elements of window functions, how partitioning works, and how ordering and framing of windows works. In the next lesson, you will learn about the different kinds of window functions that SQL Server supports.